We're looking at section 2.3. 2.3 is talking about quantities that are proportional or unproportional. That just means that their ratios are constant or the same. So that means that doubling one would be doubling the other. And when we're talking about this ratio that's constant, it's called a scale factor or a constant of proportionality. And it can be found by just scaling one of the quantities to 1. So for example, I have this set of rectangles. One has a side of 30 centimeters and the other one is 6 centimeters. And if I want the ratio for those two sides, I can set the 30 over 6 and I get 5 over 1. So then we would say that the ratio of the larger rectangle to the smaller rectangle is 5 to 1. Or we could also reverse that and say the rectangle of the smaller one to the larger one is 1 to 5. We can do the same thing with this triangle. So we're taking the 12 and the 6 because they're corresponding sides. And we're setting up our proportion, our ratio, and we find that 12 over 6 is equal to 2 over 1. So we would say that the ratio of the larger side to the smaller side is 2 to 1. So we can use proportions to find values or set up proportions to find answers. So for example, here's a comparison of euros to dollars. And what this is saying is that every 0.8 euros is equal to $1, or for every dollar you could convert it to 0.8 euros. So if I had 4 euros and I wanted to know how many dollars that was, I can set up a proportion with the 0.8 and the 4 and the 1 and the x, and then I can cross multiply and I find out that the value for x is 5. So that means that 4 euros is equivalent to $5. I could do the same thing here. If I had $15 and I wanted to know how many euros that would equal to, I could set up the 0.8 over y and the 1 over 15, and again I could cross multiply and end up with y is equal to 12. So that means that $15 would be equivalent to 12 euros. And again, here's another example where we have 30 euros. $30, and that would be equivalent to 24 euros. Notice also that the number of dollars for the bottom two examples, the number of dollars doubled and the number of euros doubled. So that constant is that ratio is a constant value that happens all the time. So here might be something a little bit more familiar for some of you. So let's say I have a recipe that calls for a cup of flour and 1/4 of a cup of sugar. 1/4 of a cup would be 0.25 cups. So how much sugar would I need if I had 2 cups of flours? Well, I could set up my proportion, so 1 cup of flour equals 0.25 cups of sugar. So 2 cups of flour equals how many cups of sugar? So in this ratio, what I'm having is the amount of flour over the amount of sugar. That can be set up different ways. So then if I cross multiply, I end up with 0.5, which is the same thing as half a cup of sugar. Now I agree that some of you may be able to look at that and say, if I double the amount of flour, I have to double the amount of sugar. And that is a way to look at this, and it's a good way to think about these things. How much flour do I need for 2.5 cups of sugar? So again, I set up my ratio, 1 cup of flour, 0.25 cups of sugar. So how many cups of flour for 2.5 cups of sugar? And when I cross multiply, I get 10 cups of flour. So that's another example that you might be familiar with. Then we talk about something called the direct variation. We're going to get into that a little bit more, but here we have an example of a direct variation graph of y equals 5x. And I want you to graph it. So some of you have learned a few different ways. One of them is to say that the slope of this line is 5 over 1, and the y-intercept equals 0, 0. So then I could graph the point 0, 0, and then I could use my slope and rise 5 and run 1, and I can get my line. Another thing you can do is just pick values for x and substitute it into the equation. So if I have 0 for x and 1 for x and -1 for x, I could pick anything I wanted. I just didn't want to pick numbers too big. So I plug the 0 in, substitute the 0 in for x, and I have 5 times 0 is 0. So I have the ordered pair 0, 0. And then I have 5 times 1 is 5, so I have the ordered pair 1, 5. And again, I can graph those points. Here's 0, 0, here's 1, and up 5, there's 1, 5. And then if I did the -1, I would get -1, -5. So those are a couple of different ways to graph that. Another example, you walked 10 miles in 3.25 hours. So what's the scale factor? So the scale factor would be 10 over 3.25. So if I scale it to 1, then that means that I would have 3.07 over 1. So what exactly does that mean? It means that I can walk 3.07 miles in 1 hour. And if I were to write an equation, I would say miles equals 3.07 times hours. So if hours is 0, that means I didn't walk anywhere. If hours is 1, that means I walked 3.07 miles. So I'm going to put out another video for you for the second part, which is direct and indirect variation.